Hi students. So I am Rekha, Assistant Professor, Department of Mathematics, Dr. S.N.S. Rajlakshmi College of Arts and Science. So today we are going to see the topic queuing theory in Model 3 and in the course Resource Management Technique. So this topic is from Unit 3. Okay, so we can see what is meant by queuing theory and also we can see the problem also in the queuing theory Model 3. So before going to that, we have to just recall what is meant by queuing theory. So everyone know what is queuing. Queuing is nothing but a waiting line. Okay. So waiting line, we used to face in day-to-day life in supermarket in order to book a ticket or in the cinema theater, or else if we wait in the barber salon, etc. Used to face the queue in that. So nowadays we are booking in the online. Whether they have a you have a queue means we are also waiting in the queue through the online also. So what are the discomforts we are going to face in the waiting line, and how to find the average waiting time, and how many customers are arriving, or how to detect everything we are going to see in the queuing theory. So we have a lot of models are there, but we have only the two models. So what are the customer, what is the basic definition? What customer, who says customer, queue, arrival distribution, service time, etc. Customer is nothing but, so if you want to find the arrival means person, waiting time will be, arrival you need some service to be performed. The customer may be a person, machine, vehicles, etc. So the number of customers waiting to be served is nothing but a queue, and arrival distribution is nothing but the jobs or a person entering in the system is known as a customer. So this used to represent as an lambda. And if you go with the service time means, service distribution means, the service is nothing but an how many customers are served in the system. So that is nothing but an service. How many customers are served at their respective time duration. So that is we can represent it as a service distribution. So we have a service discipline pattern also, first in first out, last in first out, random, and service in patterns. What is the first in first out means? First customer served as a first, last customer served as a first served. Random means randomly, if the teacher asks the question means that is random. Selection for the priority means any VIP or there means we can give a special priority for that. So what is model 3? Model 3 is nothing but an queuing model 3. So n represent the finite number of customers. So yeah, everything is same, first in first out, everything is same, but we have a limited number of customers are there. Let us consider one problem. That is queue is nothing but, if an if for a period of 2 hours in a day, train arrive at the yard of 20 minutes, but the service time continuously to remain 36 minutes. The probability that the yard is empty, and then average number of trains in the system we have to go into, and the limited trains is only 4 units we are going to, they have mentioned. So in that itself we have identified that only 4 trains will be allowed. So that is nothing but n. So here we are going to calculate the arrival rate. Arrival rate means we used to mention it as a lambda. 20 minutes we will get one train was arrived. So 1 by 20. Okay. So already they have given in the minutes means we can directly can go for that. Otherwise we have to convert into a hour means we have to convert into minutes. Divided by 60 we go on. So 36 minutes they are servicing one train. Okay, so one train will service to 36. So mu is nothing but 1 by 36. Already lambda have found out, mu is also found out. Rho is nothing but lambda by mu. So lambda 1 by 20, mu 1 by 36. If we divide both, we will get 36 by 20, 9 by 5. Okay, so dividing the value will get rho equal to 1.5. So the question is that the probability that the yard is empty. Empty means we are going to find the P naught. 1 P minus 1 by P n power n plus 1 minus 1. So P rho everything is the same. 1.5, that is P value is 1.5 minus 1. 1.5 whole to the power of 4 plus 1. So why we are applying 4? N is equal to 4? No. 4 trains only limited in that area, so that we are mentioned as 4. So dividing you will get 1.5 whole to the power of 5. So calculator 1.5 whole to the power of 5 means 18.895 minus 1. So 17.895. If you divide 0.8 divided by 17.89 means we will get 0.4470. So another question they have given. What is the another question? Average number of customer we are going to calculate. So average means 4 is limited no. So e power summation n to 0 to n we are going to calculate. So p naught n equal to 0 to n p naught means we have to apply n for 0, 1, 2, 3, 4. So the calculation is goes on 0 p power 1, 1 p power 1, 2 p power 2, 3 p power 3, 4 p power 4. So what is p value? 1.5 or 8 already we have found it. So 1.8 plus 1 into 1.5 plus 2 into 1.8 the whole square plus 3 into 1. So applying the 1.8 the whole square is 5.832, 1.8 the whole cube 10.432, or multiplying all the values and adding all the values you will get 67.748 and p naught 0.458. If you multiply this to 3.10, so this is the average calculation. So 3 trains are we are going to number of trains in the system means so we can say that it is a 3 trains. Okay, so based on that we can calculate the model 3. So model 3 is from third unit of queuing. It's from resource management technique. I think this topic is very useful, and we have the problems also. Okay, you can calculate the problems in that queuing also. Okay, a lot of problems are there, so I'll take the problem. Okay, thank you ma.